Ah, the Big Bang. A magnificent spectacle, yes? The moment our entire universe, with all its wonders, is said to have burst forth from... well, from what exactly? We picture it as the grand starting line. But what if I told you, with a twinkle in my old eye, that this starting line might just be a checkpoint in a much, much longer race? What if there was something before? Buckle up your brain cells, my curious friends. Because today on Synaptic Science, we are venturing to the very edge of understanding, perhaps even beyond, to explore the wildest, most mind-bending question in all of science. What happened before the Big Bang? Now, our best scientific story, the standard Big Bang model, is a triumph. It tells us that about 13.8 billion years ago, everything we see and everything we are was squeezed into an unimaginably hot, dense state. Einstein's theory of general relativity paints a rather good picture of this expanding universe, how it cooled and how stars and galaxies formed. But, like any good story, it has a chapter that's, well, a bit smudged. As we trace time backwards, closer and closer to that initial moment, general relativity, bless its heart, starts to wave a white flag. It predicts a point of infinite density and temperature, a singularity. Imagine all the energy and matter of the cosmos in a space smaller than an atom. But at this extreme scale, the laws of the very large, that's Einstein's general relativity, must shake hands with the laws of the very small at quantum mechanics. And this handshake, my friends, is where things get tricky. Our current physics can't quite describe this Planck Epoch, the very, very first fractions of a second. It's like trying to read a book with the first page missing. So, the Big Bang describes what happened from that hot, dense state onwards, but the before, or even the at the very instant of, remains shrouded in mystery. So if the Big Bang wasn't the absolute beginning, what could have come before? One fascinating idea is the Big Bounce, or a cyclic universe. Imagine our universe isn't a one-time show, but more like a cosmic accordion, or perhaps a magnificent cosmic yo-yo. In these models, a previous universe might have existed, expanded, and then, instead of ending, it began to contract, collapsing in on itself in a big crunch. But instead of crunching into an infinitely dense singularity, quantum effects, those funny rules of the tiny world, might have kicked in, causing it to bounce and re-emerge as our Big Bang, starting a new cycle of expansion. Some theories, like those involving loop quantum gravity, explore this very possibility, suggesting the fabric of space-time itself prevents a complete collapse. Now, a tricky part for these cyclic models is something called entropy, the universe's tendency towards disorder. Each cycle could be longer and more disordered than the last, which implies there still had to be a first cycle somewhere. However, clever physicists are working on newer cyclic models, perhaps involving extra dimensions or new forms of energy that try to solve this entropy puzzle, allowing for a truly endless series of cosmic rebirths. Another mind-stretching possibility is the multiverse. What if our Big Bang, our entire observable universe, is just one bubble in a vast cosmic ocean of other universes? This idea often arises from a concept called eternal inflation. Picture this. The very early period of super rapid expansion, which we call inflation, more on that in a moment, might not have stopped everywhere at the same time. Perhaps, in the grand scheme of things, inflation is still happening, constantly spawning new universes, each a pocket or bubble universe that pinches off from the inflating background. Our universe would just be one such bubble that stopped inflating locally and cooled down enough for stars and galaxies and us to form. And here's a really wild thought. These other universes could have entirely different laws of physics, different fundamental constants, perhaps even different dimensions. Imagine universes where gravity is stronger or light travels at a different speed. The possibilities are, quite literally, infinite. Now, I mentioned inflation, and it's a crucial piece of this cosmic puzzle, even if we are talking about before the main hot Big Bang phase. You see, the standard Big Bang had a few tricky questions like, why is the universe so incredibly uniform on large scales? And why is it so flat? Cosmic inflation, a theory developed in the 1980s, proposes that in the tiniest fraction of a second after the initial moment, whatever that was, the universe underwent a period of absolutely staggering exponential expansion, growing from subatomic size to something like a grapefruit, or even vastly larger, almost instantaneously. This super-fast stretching would have smoothed out any initial wrinkles, explaining the universe's uniformity and flatness. And here's the fascinating bit for our before question. Inflation effectively erases many details of what might have preceded it. It's like trying to find footprints after a cosmic hurricane. However, inflation also proposes that tiny quantum fluctuations during this era were stretched to enormous sizes, becoming the seeds for all the galaxies and cosmic structures we see today. So, while it might hide the ultimate beginning, inflation sets the stage for the Big Bang we know and love. So, what truly happened before the Big Bang? The honest answer, my dear viewers, is we still don't definitively know. It remains one of the deepest, most profound mysteries in all of science. Each of these ideas, bounces, cycles, multiverses, the precise nature of inflation's trigger, are theoretical frameworks, mathematical explorations pushing the limits of our imagination and our current physics. But that's the beauty of science, isn't it? The unknown beckons. Physicists around the world are, and theorists are refining these ideas, looking for potential observational signatures. Could clues be hidden in the subtle patterns of the cosmic microwave background radiation? That faint afterglow of the Big Bang? Or perhaps future gravitational wave observatories might detect echoes from an even earlier epoch, maybe even from a previous universe's crunch, or the birth of our own from a multiverse sea. It's a grand detective story at the cosmic scale. The quest to understand our ultimate origins is a testament to human curiosity. While we may not have all the answers today, every new theory, every new observation brings us a little closer. What do you think came before the Big Bang? Let us know in the comments below. And if you enjoyed this journey to the edge of time, don't forget to like this video, subscribe to Synaptic Science for more mind-expanding adventures, and ring that notification bell so you don't miss our next exploration. Until then, keep asking questions and keep exploring the wonders of the cosmos. Thank you and goodbye.